question number 3. Show that the equation 7 tan theta over cos theta plus 12 is equals to 0 can be expressed as 12 sine square theta minus 7 sine theta minus 12. Okay, so this is a simple question of trigonometry, and we know that whenever tan theta is given, so we use tan theta to be equals to sine theta over cos theta. Secondly, we use in these proving identities type of questions, we use any version of this formula. Okay, so let's begin. So 7 times tan theta, so I'm writing it as sine theta over cos theta plus 12 equals 0. Now, okay, also we have cos theta in the denominator. So now when we simplify it in one more step, it becomes 7 sine theta over cos square theta plus 12 equals 0. Now what we can do for this, we take cos square as common denominator. So for this reason, we can multiply this numerator and denominator by cos square theta, or directly do this. So it becomes cos square theta 7 sine theta plus 12 cos square theta equals 0. Now we know that we are supposed to use any version of this formula. So side by side you can write what you are doing. And here we will be using cos, as we have the final equation in form just sine theta. So let's substitute this cos theta to be equals to 1 minus sine square theta. Cos square theta equals to 1 minus sine square theta. So it becomes 7 sine theta plus 12, 1 minus sine square theta over 1 minus sine square theta. Or just simply we can just shift this one on the other side and it becomes 0. So we can just leave it in this one as it is, and we are left with now 7 sine theta plus 12 minus 12 sine square theta equals 0. And if we need the exact this form, so we can multiply the whole equation by minus 1. It will become 12 sine square theta minus 7 sine theta minus 12 equals 0. So multiplying by minus 1. Okay, so this is proved. Now secondly, we have part B to this as well. So part B says, hence solve the equation for theta to be between 0 and 360. So the range is given, and now we have to solve this using the above part A. So we have already proved that this is equals to this. So we are going to use this directly. So it would become 12 sine square theta minus 7 sine theta minus 12 equals 0. So now this is a quadratic equation. Okay, so we can directly solve it as it is, or You can substitute sine theta to be equals to any other constant x or t or any other variable, and then you can solve this quadratic equation. I'm doing it directly. We minus 7 minus 12. Okay, fine. So we need two factors that when multiplied should give you the product of outer two terms, that is 144, and when added or subtracted it should give you minus 7. So which two numbers are like this? It will be minus 16 sine theta plus 9. Okay, this will give you, on multiplication will give you 144, and upon adding you will get minus 7 sine theta. So yeah, okay, so my plus 9 sine theta minus 12 equals 0. So taking 4 sine theta now common, 3 sine theta minus 4 plus 3 is 3 sine theta minus 4 equals 0. So we get 3 sine theta minus 4. So these are your two factors. So from here you get either 4 sine theta plus 3 is equals to 0, or 3 sine theta minus 4 is equals to 0. So sine theta will be equals to minus 3 over 4, and sine theta equals 4 over 3. So when we do find the angle, we take the basic angle ignoring the sine, so we get basic angle to be sine inverse of 3 over 4, and as we have the angles in degrees, so we'll solve in degrees, and we get the angle to be 48.5903. This is the basic angle. Okay, and for the other part, 4 over 3 is something 1 point something, and sine inverse of one greater one, or like greater than one value is not possible, so because the maximum value could be 1. So this part of your working is rejected because this is not possible. Okay, now this is your basic angle, but we don't need the basic angle, we need actually the angles. As we know, the sine was minus 3 over 4. This was minus 3. So that means we need the angles in the quadrants where the sign is negative. So where the sign is negative? The sign is negative in, this is your A, S, T and C. So the sign is negative in here, third and fourth quadrant. So we need angles here and here. It becomes a little, okay. A and S are the two quadrants where the sign is positive. So we are taking now the first angle would be 180 plus alpha. Okay, this would be like this, and the second angle would be 360 minus alpha. Okay, alpha is your basic angle, this one. This much is your basic angle, and this much is your basic angle alpha. But your actual angle is 180 plus alpha, and this one would be the second one would be 360 minus alpha. Okay, so now finding it out, 180 plus alpha is 180 plus 48.5903. So this gives you 228.5903. And the second angle is 360 minus alpha. So 360 minus 48.5903 will give you 311.4096. So these are your two angles or the solutions of your this one and this one. This is your theta value. Okay, this is your final answer. So this is how we solve our question number 3 part B. I hope you understand the question.